In 1999, Yoonho Kim, Yu, Kulik, Shi and Scully successfully performed a delayed eraser-type double-slit experiment. The results clearly showed the influence of the which way information regarding the collapse of the wave function. In this video I will not show the basic operation of the experiment, and I assume that you know how all the elements work. The main idea here is based on the against consensus interpretation in which the principles of causality are violated. So you may find some ideas here surprising or unrealistic. For reasons of simplification, I have suppressed the detectors D3 and D4, BSA, BSB, as well as the part of the coincidence counter. Actually, we will run the experiment mentally, so for now we only need 2 detectors and a beam splitter that can be turned off and on at will. I will start by answering one of the questions that many people have regarding this and other delayed choice experiments. What pattern can be observed on the detection screen D0 when the photons of the idler part have not yet been absorbed by D1 or D2? Remember that although in the animation only 1 photon is emitted at a time, for our thought experiment we used 100 or more. But in any case, it is also possible to deduce the type of pattern with a single photon by the position of the absorbed photon in the screen. Since even though the position is random, it is within the fringe probability or outside the fringe, depending on whether the wave function was collapsed or not. The answer to the question and what the real experiment showed in D0 is always a pattern according to the setup, BSC is on or BSC is off. At first glance it seems that the result in D0 while the idler part has not finished yet should always be an interference pattern, since which way information is undetermined at that time. Retrocausal hypothesis says that the wave function collapses retrocausally in such a way that if at the end of the experiment the information which way has emerged, then the wave function returns to its origin in space and time, that is, before the double slit. That is, from the observer's point of view the wave function goes back in time, just at the moment it was emitted. But now the wave function is collapsed, and in this case the photon actually passed through the blue slit. For this reason, the observer does not see an interference pattern in this case. There was, but that timeline was discarded. But not only the interference in D0 was ruled out, but also any reality that depended on it. Another frequently asked question is what happens if at that moment we activate or deactivate BSC to contradict the postulate, which way, in relation to what is observed in D0? Following the previous reasoning and that the results must match what we will do in the experiment setup, we would be in a time loop now so that the wave function travel to the moment of origin continuously. However, this approach is totally incorrect because, first, from the observer's point of view, the photon does not travel to the past, the wave function does. Second, because the experiment ends when the signal photon is absorbed by D0. What we do later in the setup no longer affects D0, because the wave function has already collapsed and is irreversible in this case. In other words, if it were possible to observe D0 and at that precise moment change the state of BSC, nothing would change in D0, since the fact of observing is already indicative that reality is already defined, or, in other words, D0 wave function has already been added to the universal wave function.